I am Sara Lucatello, the Vice President of the EAS, one of the Vice Presidents of the EAS, and I will be moderating the session. As you all know, the new space economy development and explosion of satellites in the last few years has given rise of a number of concerns related to astronomy and the protection of the dark and quiet sky in general. This is, of course, part of a larger issue, that of space sustainability, which is to ensure that space will be a resource that we as humanity can continue to use in the future for peaceful purposes and for the benefit of us all. Today, to talk about the issues related to dark and quiet sky and satellite constellations, we have three people who are not only experts in the field, but have also been key in effectively bringing the concerns of the astronomical community to operators, policymakers, and funding agencies, and help define a path forward that hopefully will ensure a future of astronomy without encumbering the plans or the benefit that we all as humanity get from space, from the use of space and commercial use of space. So we have Robert Massey, who's Deputy Executive Director of Royal Astronomical Society and is the chair of the EAS Satellite Constellation Working Group, will be our first speaker. And then we will have Federico Di Bruno, who's Spectrum Manager of the Square Kilometre Array Observatory, and also the co-director of the International Astronomical Union Center for the Protection of the Dark and Quiet Sky from Satellite Interference. Then we have Andy Williams, who's External Relation Officer for the European Southern Observatory, and is co-chair of the IUCPS, the center above mentioned Center for the Protection of Dark and Quiet Sky from Satellite Interference for the Policy Hub. We will have each speaker have a short presentation, and then there'll be a few questions from the audience related to that presentation. And then as the last speaker finishes, we will open a period of discussion and Q&A session in general. So now give the word to Robert, who will start his presentation. Take it away.
Thank you, Sarah. And the first thing I will do, of course, is to get that presentation shared. So looks good for me. So I hope everybody can see it. Great. Excellent. Okay. So, Sarah really sums this up quite well. In a sense, we're here today to talk about the EAS efforts in this area, but Federico and Andy are much more specialists in the areas of things like the CPS and the work of the European Southern Observatory of ESO. So when I pull these kind of things together, I always think that, it's actually quite instructive to have a basic overview as well, to think about the landscape of the problem and the kind of things we've been doing to impact on that. So I think it's appropriate always to start, very briefly with an unfettered night sky, actually the kind of thing that we would aspire to. And even if we're, even for professional astronomers, even say people working on theoretical astronomy with, marginal access to observations or marginal use of facilities, I think we would regard that kind of view of the sky as something we want to preserve and something that's important. And of course, traditionally we do that or access to things like this by escaping urban areas and associated light pollution and try to find remote sites. And of course, those are the places where optical telescopes and radio telescopes are sited away from sources of optical and radio interference. And I think in this, I always also think it's appropriate to say that to some extent, we've been here before a long time ago. Those of us who were at the meeting in La Palma, either virtually or in physically there last autumn, will have been reminded by Lisa Ruth Rand from Caltech that there was Project West Forward right back in 1961, where the US decided to deploy 480 million copper dipole antennae with a perceived and real risk to then the emerging science of radio astronomy. And there were protests by my own organization, the Royal Astronomical Society, the Soviet Union, perhaps unsurprisingly, and also, which surprised me a lot more, there were actually protests among the American public as well. So, I think I put this example up because we've seen this kind of before, albeit 63 years ago, but also that there was public interest at that time. And it's my view that it should be possible to cultivate that now as well and to continue to bear that in mind, that we can kind of persuade the public to be interested in this. Needless to say, that project didn't develop in quite the way that it had a massive impact, but there are still some of these needles in space to this day. So I think there's a few tens of thousands up there. So The context for all of this, you might ask not unreasonably why we're concerned about this now, whereas obviously the number of satellites has been growing over the decades. And it's really that kind of step change with the development of what's called the new space economy that Sarah referenced earlier. The idea that the use of low Earth orbit in particular, so under 2,000 kilometers altitude, becomes that much busier. So in 2019, there were around 2,000 active satellites. And if you add in the deployments by Starlink from SpaceX, the OneWeb constellation that's owned by the UK and others, you now reach a total of approaching 10,000. And that's just so in the last 4 or 5 years, we've seen a quintupling of the number of satellites in that position. And this looks like it's just the start. It's very hard to know exactly how this will go because of market access and commercial considerations, all of those things. But we could, if you believe all the license applications, be looking at, say, 500,000 satellites sometime in the 2030s. Now, will it be quite like that? Well, we don't actually know because it depends on the financial viability of the companies concerned. But, imagine going from 2,000 to 500,000 just in the space of, say, a decade and a half or so, that kind of, increasing by a factor of 250 the number of active objects in low Earth orbit, let alone associated debris. People like Andy Lawrence and so on have looked also, and also Jonathan McDowell in the US have looked at how this plays out over time. I should also mention Hugh Lewis, who does a lot of work on space debris too. If you track this again, you see there's this uptick in the blue line, the number of active satellites, and then various other events like the Chinese weapon tests, the collision between Iridium and Cosmos and so on that ramp up space debris. But the point is that this is a growing problem. There's absolutely no sign of any kind of slowing down in this, and the exploitation of space continues. We're not here to talk about debris particularly, but it's worth noting that back in 2022, this is some work by Hugh Lewis, there were 4 million so-called conjunctions between satellites, which means they came close and in many cases had to do orbital maneuvers, something that becomes increasingly necessary as the population of low Earth orbit increases. And the players in this, well, you can look them up for yourself, but the biggest is Starlink, the one we're most familiar with, and there's just an illustration of what a Starlink satellite looks like in orbit there at top left. At the bottom is the sort of famous, that kind of bus deployment they're very proud of, where they do a launch and launch tens of satellites at once. And there are other players, OneWeb I mentioned, but also AST Space Mobile, who concern us simply because the size of, the size and the number of objects they're deploying, tennis court-sized satellites that become very, very, potentially very bright and very, very visible. And then Amazon Kuiper and also IRIS that I mentioned from the European Union and Guowang from China and so on. So we are seeing an ongoing development. And there are other actors, other countries that are expressing interest in finding applications. So very pertinent to the EAS itself is the EU or European ambitions. A story flagged a few years ago. The EU proposes a 7 billion euro constellation, IRIS squared, I'm sorry. And that's the idea of that is to tackle internet dead zones. Now that's sort of a similar aspiration actually to SpaceX and Starlink, but in Africa as well as Europe. Might be built by the European Space Agency, and European companies will, likely be involved in that. So, this is an example actually, which I'll come back to, where we just have some influence over it, and we continue to do so because the EU sees the EAS as a kind of natural consultative body to work with. And what does it mean, all of this? Well, I mean, the other speakers can talk about this too, but bluntly, optically, it means that you don't escape from the influence of satellites in the same way that you do from other forms of light pollution, because wherever you are on Earth, almost by definition, it's possible to see these things deliberately, because after all, if you're talking about an internet constellation like Starlink, then you want to be able to, for its customers, it needs to be covering the entire globe or most of the populated globe. And yeah, satellites shine through reflected sunlight, as people on this call would doubtless know, and that means that if you have a long enough exposure, you start to see streaks as a result. Now, a lot of the early images that were released on this, which I've included here, are slightly contrived in the sense that, I think given that they were made in 2019, when there's a relatively low number, in most cases, 2019, 2020, you're pointing a telescope, a camera at a part of the sky where you know that the constellation is going through. Well, what it does demonstrate is that in the absence of any mitigation, of any corrections and so on, you see lots of streaks, as you would expect, like star trails do on amateur astronomers' camera. And on the left, that was the classic one from Victoria Gergis at Lowell Observatory at the bottom there. Bottom left is one showing as well, of course. We can remember that this affects telescopes in low Earth orbit too, particularly Hubble and anything else that we plan to deploy in that position. Obviously not James Webb because it's much further out. On the top right, you've got an image from a meteor all sky camera. And, you know, if you're familiar with these things, you'll see there are, in fact, some meteors in that image. But the point is that it's dominated, well, there's a few examples of plane trails, but also by satellite trails too. So there are certain aspects of astronomy that are much tougher to do as a result. And I guess something like meteor science, these kind of things would be an example of that. And then if you want the example of how, well, space junk in general interferes, was a classic detection of what was thought to be the optical counterpart to the oldest gamma ray burst ever discovered, and it turned out to be a rocket body, a piece of space junk. You know, and I guess the consequence of this is that we may see more of those as time goes on. Federico, I'm sure will want to talk about this in more detail than I'm going to, but this obviously also has a major impact of radio wavelengths as well. On the left is an image made from the Quixote telescope in Tenerife, actually before the deployment of these constellations. And what you can see there in the radio sky, yes, obviously the sun, the galactic plane, but that belt running across, which is the geosynchronous satellites, the signals from those. Now, the issue for radio astronomy, bluntly, is that the signals, if you have, say, a downlink signal from a satellite designed to deliver internet access, that is many times, i.e. up to 1 trillion times more powerful than the weakest radio sources. So the challenge for radio astronomers is how on earth to manage that kind of scale if you're presented with something which is that bright at radio wavelengths. And of course, the answer is that you don't want it transmitting over your observatory. However, the solution, as with the optical, of moving that to a remote site, so in the case of, say, SKO, to move it to Western Australia and Southern Africa to be away from ground-based radio interference, is not going to help you with satellites orbiting above it. So, you know, there are obviously discussions going on with companies about how to manage that. And another aspect of this as well is that satellites, the rules around regulation of radio interference and electronic components on satellites are weaker than they would be on the ground. And so for observatories like NOFAR, and I know Federico is the lead authors on a paper on this, is that interferes too. That, you know, some radio telescopes are certainly easily sensitive enough to detect that as well. Now, one thing I will refer to just in passing, because I think it's worth noting, although it's slightly outside of our purview in terms of our expertise, but I think it's a really important thing to be aware of, is the environmental impact of all this as well. So perhaps when you're looking at, say, a few tens of launches a year, we didn't worry too much about that. But if we get up to the scale when that becomes hundreds and you're talking about thousands of deployed satellites a year, the real concerns about, A, the impact of that many launches, because, you know, even the cleanest launch, usually those fuels are made through some kind of carbon intensive process. What happens when that material re-enters too? And there are, you know, different papers on that. You know, for example, Aaron Bowley and so on has done some work on this, noting the ramping up in the amount of aluminium entering the atmosphere if you have the supposedly, well, it's debatable, good space practice of burning up satellites once they reach the end of their life. That's good from a debris perspective, but we might argue that we're then treating the upper atmosphere as we did the sea, just as dumping ground without thinking hard about the consequences. Now, I should say that this is not by any means you know, it's not settled science. But at this point, I think it's absolutely right that, you know, for example, there's funding from the European Space Agency and so on, looking at what the effect of this actually is. And, you know, to my mind, it's important that we think about that in the broader discussion before we just say, as some do, yes, space is great, let's fill it with stuff and maximize the use of it, and just go through that existing practice of disposing of satellites in that way at the end, apart from the fact that then there's a resource issue too. And so we've seen discussions around whether it's possible to have a circular space economy and to reuse some of these things more. The cultural impact, to my mind, also we have to be mindful of too. You know, and these are good. These are in many ways, as with the environmental, you know, the environmental issue, I think it's an opportunity for us to build alliances, and we've seen those kind of discussions in the meetings convened by the IAU and others. We should think about, given this is a global issue, the rights of indigenous peoples affected by that. You know, the UN declarations protect their rights and their culture. And in many of those, the night sky above our heads is a core part of that. Now, it's used in things like navigation, as I mentioned in that bullet point there. But also, I would argue that not just, you know, it's in the worldview of certain indigenous peoples, and I wouldn't want to suggest there's only one you know, there's many different peoples and many different views of the universe. But also I would argue that wherever you are in the world, there's a heritage issue here too, that we have that right, or the wider public has that right to be a stakeholder. So it isn't just about big corporations and private companies deciding this and governments seeing it as a good thing inherently without that criticism. So, you know, it is to some extent in conflict with the growth of dark sky places all over the world that we've welcomed dark sky places that we've seen, and the Starlight Declaration, which was signed back in La Palma in 2007. So you might then ask, well, what's being done to regulate it? The answer is not a great deal, and the issue is that it's been described to some extent as the Wild West. That actually, you know, it's the regulations are in place are not really fit for purpose to cope with this big expansion, and they certainly don't really cover optical astronomy. So you've got things like the Federal Communications Commission in the US, Ofcom in the UK, the Bundesnetzagentur in Germany, and so on, and the ITU as the global UN body on top of those. And they're supposed to manage the filing of satellite deployment. But what they don't do is protect the night sky, except for a very limited amount of protection of radio wavelengths. And those bands, I think, were established in the 1960s. So long before the kind of growth and use of the radio spectrum that we've rightly seen and welcomed. And remember, you know, you could manage that alongside all these other users as long as you were far away from inhabited places, as long as you had radio quiet zones and so on. In the absence of those, it's a much more difficult problem. And it's certainly, let me rephrase that, if you're relying on remote location and you have satellites filling your sky, then it's a much more difficult problem. And there is no optical equivalent to this. The ITU is not interested really in optical wavelengths, understandably, and because, you know, they're about telecommunications. And at the moment, although we're succeeding to a certain extent in raising it on the agenda of policymakers, there isn't very much regulation around that at all. So the EAS working group was created in around, I think, 2020 or 2021, after a whole series of astronomical organizations expressed concern, as we will want to do, after the first launches in the summer of 2019. I mean, you know, I think it's probably our colleagues in radio astronomy would have said, well, we knew this was coming, but I think a lot of the people working in other aspects of the field didn't, and were quite surprised and a bit shocked by the plans that rolled out quite quickly. And that group includes, you know, the observatories and satellite operators. It's more of a consultative body now than the working group in quite the same way that it was. And that's partly because the creation of the CPS, the Center for the Protection of the Night Sky, the Dark and Quiet Sky from Satellite Constellations. It's quite a mouthful, which is doing a lot more work on this now. But the point is made by people involved with those that if you want to lobby at a regional or national level, the IU doesn't see that as remit in quite the same way. So the EAS has a vital role to play in that. It's really, really important. And I give due credit to Sarah for the enormous amount of work she's done in this area. The kind of things that it's been doing, well, lobbying the European Union, so specifically responding to consultations. For example, the design of the tender for the IRIS squared constellation was influenced by the EAS. Things like the EU space law, which Andy's done an enormous amount of work on as well, and some of the new standards around there. But it includes at least virtual meetings with Commission staff, with MEPs. I mean, the German Green MEP, Nicholas Ninas, was very interested in this. The national societies also played a great role in shaping that too, by writing letters to their MEPs, as a result of which we had things like a question in the European Parliament from a Slovenian member, and an advice on those positions too, and the kind of work that's going on in individual EAS member states, sorry. And the EAS is also now an observer, again, you know, credit to Sarah for this, at UN COPI, as part of this so-called group of friends who are there, along with the IEU and ESO and SKO, and probably miss people out, and you know, aligned to countries like Chile and Spain and so on, which, as hosts of astronomical institutions, are particularly interested in protecting dark and quiet skies, so good allies in this. And some of the results then, I'm going to bring this to a close and allow the other speakers to come in, but the European Union was supporting the nod to this, the sentence about this in the declaration by the G7 Science and Technology Ministers meeting last year. That was in Sendai. The IRIS tender, as I mentioned, has considered mitigation of this. A big achievement. I mean, you know, massive credit to people like Andy and Sarah and Federico again for this. Dark and quiet skies are on the UN COPIUS agenda for the next 5 years, which I think is really a great achievement. I mean, it's painfully slow, I suppose, is my view, compared with the pace of launches. And if only it was possible to move the UN and to move international governments to create international frameworks as quickly as SpaceX puts things in space. But hey, it's a great start. Uh, and then, my own country in the UK, one of the things that's happening as a result of the overall political pressure is the ESSI, the Earth Space Sustainability Institute, actually, I should say, rather than initiative. I think they've updated their logo now, which is mostly UK based, but does have an international reach. And I'm on the board of that, and I look forward to seeing how they work with the CPS and others. And there's the two of the things I've underlined there at the bottom, which I think are vital, and the dialogue with industry that's going on through these groups, and that overall political awareness too, which I don't think we should lose sight of. It's absolutely vital that we continue that, in my view. And so what's next? Well, the ES is supporting the CPS, and people like Sarah and so on are working very closely with that, and I'm on one of the hubs for that too, the policy hub. I would certainly encourage everybody to be involved with that if you're not already and interested. My view is we just have to keep the politics going on this at national level, at European level, and wherever we can, because it seems to me it's one of those problems that you have to use all the levers you can to make it work. I also think it's vital that we carry on engaging with the media on it as well, and don't let it slip off the agenda. Whenever there are interesting things to say, we should do that. And the public, I think the outreach side of it should not be underestimated, making people aware of all of that too. That headline on the right, by the way, I particularly like. It's slightly sensationalist, but that's what a tabloid does. But on the other hand, it's also not entirely inaccurate, right? If you're trying to look for ET signals and there's bad radio interference, that is going to become more of a challenge. And then the final point there, more work on the environmental aspects. We should consider how we work with different players to engage on that as well, and actually really be enthusiastic about supporting the scientific investigation to establish the magnitude of the problem. So if you're on this and you want to help a bit, well, there will be more work. There will be more letter writing campaigns. We will ask EAS members to do more of that as well, and to write to national societies to encourage people in respective countries to that. The EU space law discussion will pick up again. It would be a good time to engage with that. And also, I think if you're aware of any particular concerns, then alert people like me, or particularly people like Sarah, Federico, and Andy, and so on, via the CPS, if things are happening, because it's hard to keep track of it all, actually. This is one of the things where regulators and space lawyers and company lawyers have a much better ability to stay on top of this stuff. And it's very hard, given that many people involved in this have other parts of a day job, to keep on top of that. So do feel free to do that. Do contact us with any points of interest you have and any other concerns. And so, look, I hope that's been an initially helpful introduction to this. I'll bring it, the other two speakers will come in with a lot more detail. But in the meantime, I'd be happy to take any questions. So I'll leave it there. Thank you.
Thank you, Robert, for this fantastic intro. And now I invite our audience, if they're interested in asking questions specifically to Robert, to to write in the Q&A session. There is a Q&A button on your screen that you should be able to fill in a question, and then Robert will be able to answer. Yes. Have a comment, actually, from Quentin Parker. Given the relevance of space debris to this topic, I would just like to bring up this conference on this issue here in Hong Kong in December 2024. Thank you very much, Quentin, for this point. In fact, space debris is a related issue, and this is something that also astronomy will have to worry more about, because there are studies indicating that space debris itself might become an issue in terms of reflectivity for the night sky when we have next generation instrument that will be able to look.
There was a paper, wasn't there, a couple of years ago, saying even the existing population is adding to background light pollution, at the sort of 10% level, at the level where the IU would consider it to be a light polluted site. So, so even remote observatories are already affected.
Absolutely, indeed. And this was, as you said, a couple of years ago, and now we're, looking at an increase in debris even more. There's another, done. Okay. Any more questions from the audience? If not, we will move to our next speaker, and you can keep your questions for the end. There'll be an opportunity to have a discussion then. And Federico, the floor is yours.
Okay, great. Thank you. Let me try to share my screen. And I'll say I have a tough job after Robert's very good introduction. And I hope I'll try to skip on some of these slides because part of it Robert mentioned. I will maybe make some other remarks, disagree on some things that Robert said, as we all do normally. But yeah, thank you very much for first of having me and for everyone for taking the time to listen to this. My name is Federico Di Bruno, and I work at the SK Observatory, and I'm also the co-director of the AU CPS. Okay, so let's start talking about the changing space environment. Robert mentioned this, so I won't go too much into the details on the numbers, how many satellites are there. As you see, right now, we have about 8,000 satellites in low Earth orbit, whereas in 2019, there were about 2,000 satellites there. So yeah, this is a really, really big increase. And here's a very nice picture of Leo Labs. Of course, this is a graphical representation, right? This is not to scale, but it shows you how busy low Earth orbit is. There are, of course, many benefits, right, on having satellites in orbit, and we all depend on satellites for connectivity, for having better data, so that we can make better decisions. Of course, like being in space is the best place you can be to look at Earth. So it's very important to have satellites there and making all sorts of data so that we can do emergency response, weather prediction, and so on. Also, we use them for positioning and timing, right? We use GPS all the time, GNSS. And space is a very important capacity building activity, right? For many, many countries. Lots of countries are trying to get into space and then building their capacity in space. And there are also some future plans, like space solar power plants you might have heard of, which for us in the astronomy world concerns us a little bit. From the environmental perspective and the energy perspective of the Earth, it makes a lot of sense. But of course, it does concern us a lot. There are also some other things like manufacturing space or data infrastructure in space. So, of course, this brings concerns. Robert mentioned this before on space debris, on collisions. So this is all about space right now. So it's not too much talking about astronomy. But as you see here in this graph on the right, when the number of total objects, this red curve, solid curve on the top, had some very steep jumps, or very abrupt jumps. These were different events, like very unfortunate anti-satellite testing events, where a country decided to blow up one of their satellites with a missile, and it produced a lot of debris in low Earth orbit. Or there were satellite collisions back in 2009. So, and you see that the rate of these probable collisions is expected to be increasing according to ESA. So there's a lot of concerns on space debris and collisions. And also Robert mentioned this, there are many unknown side effects, right, on atmospheric pollution, on human safety, on re-entry of satellites, right? There were a few pieces of satellites. There was a news recently about a casing of a battery from the ISS, which ended up in someone's house and punched through like 2 stories of the house. So that's a scary thing. So there are some concerns in there. These are all under study right now, right? So hopefully people will get on these studies and have more precision on this side effect. Okay, so now let's go to our part of the changing skies and what all this activity means for us, for astronomy. So you might seen videos like this on the right, where people started to see these trails of lights in the sky, and they didn't really know what it was. Some of them started to think that they were aliens coming from somewhere. Of course, this is not the case, right? This is just sunlight reflecting on satellites when the satellites are revolving around the Earth, and we as observers are going into the night, and the light is reflecting from the satellites, so we see them like this. Robert did mention this part, so you can have trails on images on Earth. You can have also trails on images from telescopes in low Earth orbit. if it happens that the orbit is lower than the satellite orbits, like in the case of Hubble, which people went into the archive of Hubble and they found all these types of stripes in Hubble images. And you can see that these are more blurred than the ones from Earth because the distance is shorter, right, from the telescope to the satellites. The impact on satellite brightness into optical telescopes, it has a lot of dependencies, right? It depends on the field of view of your telescope, but what the astronomical community has discussed and we established as a limit is to aim for -7 magnitude. This has two origins. One is the naked eye threshold. So the idea is that if satellite companies are able to have less brightness than 7 magnitude, you couldn't see these bright lights moving in the sky. So there wouldn't be a change on the appearance of the night sky from an observer point of view. And it also coincides with the CCD saturation threshold of some very important telescopes, like, for example, the LSST. So in this case, if satellite constellations are able to achieve this magnitude level or less than this magnitude level in brightness, it means that the CCDs will not saturate, and so some correction methods can be applied, right? Whereas if your CCD just saturates, you lose the complete image because of interference, light interference, let's say. Of course, the trick here is that brightness depends on a lot of different factors, like the design, like the material, the geometrical design, materials, the orbital altitude of the satellite, because if the satellite is higher up, you see it for more time, the observatory location, and also the time of the year, right? Depending on where the time of the year is, you will see more or less satellites, as you see here on the right in this paper by Stan Lawler and Aaron Bowley. Okay, so that's on the optical part. On the radio part, the thing is similar, but slightly different. So in radio emissions, we look at two different effects. One effect is the downlinks of satellites, so very strong signals sent to the Earth, because satellites need to communicate with Earth, right? So they want to bring internet connectivity, for example, so they beam very strong signals compared to radio astronomy signals. They beam very, very strong signals to Earth. And these downlinks can be nearby radio astronomy bands. I'll talk about this a little bit later. And they can also impact radio quiet zones, right? When radio quiet zones, we look at much broader frequency range than the radio astronomy bands only. And there's another effect that not only satellites transmit intended signals, right? So they want to communicate with Earth, but they also transmit unintended radio emissions, unintended radio noise, right? So with any electrical device that just functions with some electricity or moves electrons here and there, will produce this radio noise, right? That's just a fact of physics. And the thing is that if you have too many of these satellites producing this, let's say, faint hum, because comparatively, these emissions, these unintended emissions compared to intended emissions from a satellite, these ones are thousands or millions of times fainter than the intended ones, of course, right? But still, if you have too many of these satellites around the Earth, the cumulative effect of that will be significant or can be significant especially for astronomical observations. And so another important thing to remark is that for the radio astronomy part or the radio part, the emissions of satellites are seen 24/7, right? So it's irrespective of the illumination of the sun. So we see satellites in the radio domain all the time. Just to clarify a little bit more on the frequency bands, we talk about satellite downlinks in the range of gigahertz, in about 10 gigahertz. Now there are many more bands in 20 gigahertz, 40 gigahertz, and 70 gigahertz planned. And as you see here, the chunks or the pieces of spectrum that are used by satellite downlinks are quite big when you compare them to radio astronomy protected bands, right? So you see here, this is a 100 megahertz band, which is protected by the ITU. So this band needs to be clean of interference. And the satellite downlinks have about 2 gigahertz next to them. And the thing is that, as Robert mentioned before, for radio quiet zones or for our new telescopes coming up like the SKA, we are going to observe a very, very broad frequency range. And that's why we go to radio quiet zones. And in a radio quiet zone, the whole frequency range is protected for radio astronomy, from 50 megahertz up to 15 gigahertz or even 25 gigahertz, which is the plan. So you see, these downlinks are affecting, let's say, a big part of the observing band. And then on the other side, the unintended emissions, we were able to measure them in low frequencies. So I cannot really say if this is an only low frequency problem. We know that normally unintended emissions are brighter, or things tend to emit more in low frequencies than higher frequencies. So we think that the mostly affected part on UEMR will be the low frequency telescopes like the SKA low or LOFAR, MWA, LWA, all these low frequency telescopes. And the important thing to remember is that there is a radio astronomy band in this frequency range, which also needs to be protected from interference. So it's not only that we need to recourse to the goodwill of constellations or operators to try to fix this issue of UEMR, but it's also a regulatory issue, right? So that this band needs to be protected. So we need to remember that. On how the sky will look like, Robert did mention a little bit on this. The sky for radio astronomy, we normally simulate it on terms of data loss, right? So we have a threshold protection and we simulate the sky in terms of data loss. So there have been several of these simulations, and basically what we will start seeing is things like this. So this is the sky as you would see it from Germany, from Effelsberg. And the coloring here shows the increased data loss in certain parts of the sky, right? Which this also gives you some tool to say that not all the sky will be lost, but some part of the sky will have greater data loss, right? So you will have to flag more data. So this is what we are seeing right now. These are all the simulations that we are working with and what we are trying to mitigate, right? So all these simulations come from a report which is called ECC Report 271, which looked into the first phases of OneWeb and Starlink in the radio astronomy band 10.7 to 10.6 to 10.7 gigahertz. But there are many other bands, as I was saying before, in 20 gigahertz, 30 to 40 gigahertz, and 70 gigahertz. Okay, and briefly, I wanted to remember the LOFAR detections on UEMR, as Robert promised that I will talk a little bit more on this. So here is just a plot from the paper that we produced with the LOFAR team. And as you can see here in this graph, this is divided by frequency. So it's frequency chunks in each one of these pictures from 110 megahertz to 188 megahertz. And the horizontal axis is time. So the 0 is the time when the satellites were going right through the beam of the LOFAR station. And you see here this brighter detections that are in different ways, right? See, here are more broadband. So they go from 110 megahertz to maybe 125, something like that. Or you can still see them in some other frequencies, but the brighter parts are here. But also we had some detections of narrowband RFI, which were much more bright. So there's a lot to unpack in there from unintended emissions of satellites, and it's early days, I would say, on that RFI effect. We are still trying to understand what the effect can be on science, and I invite you to participate in this, so that we can do more studies and we can have more tools to also make operators to care about this, right? And also regulators. We are working right now also at the ITU to create a report on this effect so that we can also start regulation moving, because unintended emissions are not recognized at the moment at the ITU. But as I was saying before, there is a radio astronomy band here in 150 megahertz, which needs to be protected from interference. So there is a reason to go to the ITU and talk about this. Okay, so that's more or less the effects, and I'd like to talk a little bit on the efforts to protect dark and quiet skies. I'll go briefly on this because I think Andy is going to go deeper. On the policy development side, there are things going on at the national policy, and also we are doing some progress there in the UN bodies. Also, Robert mentioned this before. We are working at the ITU, where there is an agenda item decided for WRC 27, the World Radio Communication Conference in 2027, where there is a revision of the international radio regulations, the use of the radio spectrum. And there is one of the agenda items, so one of the things that will be discussed in 2027 is on how to protect radio astronomy from large constellations in radio astronomy bands and in some radio quiet zones. So it's a very important discussion there at the ITU. And in COPWAS, Andy will mention more on this, but we have this agenda item on dark and quiet skies to have discussions there for 5 years. So something moving there. On the astronomical side, we established the IAU, the International Astronomical Union, established the Center for the Protection of Dark and Quiet Skies from Satellite Constellation Interference, which is CPS for short, in partnership with NOAA Lab from the US and the SKAO. And this is a virtual center. We have more than 300 members. Membership is free and open, so please go to our website and apply for membership if you're interested. And we look at the very different range of things. We go from satellite observations and in radio and optical domain, and we do software development. We have a strong industry involvement with more than 14 operators, I think a little bit more now. So we do have this interaction with industry, which is very good. And sometimes it's very complicated, right? Because we have sometimes conflicting interests. But the discussion and the conversation is very important. And so that's the route that the CPS takes, that of collaboration and discussion. We have a community engagement group and a policy development group. So before that, I'll have to say that we have many astronomy organizations involved in the CPS, like the European Astronomical Society, which we are very grateful for. They're very, very good support to us. ESO, also European Southern Observatory. We also have a lot of support from the Committee on Radio Astronomy Frequencies, CRAF, and the Opticon Radio Net program, ORP. I wanted to mention these few because I suppose that many of you know who they are or are involved in. So if you are part of any of these groups, you are taking already part of the CPS, and we are very grateful for. So I wanted to briefly tell you what things we are doing in some of these hubs, in each of one of them, starting with the Industry and Technology Hub. This hub is a little bit particular because we have industry involved in there, and an industry is always careful. They want to be careful how they interact with us, but it's really good that we are having conversations at the technical level with industry, and they are discussing between themselves about dark and quiet skies, right? It's not about how they can get revenue, not about how they can get more or less customers, and how they can surpass their competitors. They are discussing about dark and quiet skies in the CPS. So they have a technical advisory committee, which they meet with about 15 members from industry. They are working on an astronomer guide program, which the idea is to pair astronomers with companies and try to make a better relationship so that we can have a better translation between the astronomy needs and the industry needs. They work on briefing satellite industry associations. They are very strongly trying to promote test labs for bidirectional reflectivity, for optical characterization. And they are also collaborating with SatHub, which is the observation hub, in observation campaigns. And they are basically increasing the awareness of industry on this topic, which I think is quite successful so far in increasing the awareness. Policy Hub, I'll let Andy talk about this. I don't want to take away what you're going to say, Andy, so I'll leave it to you. StatHub is the observations and data analysis hub. It's more like the astronomical core of the CPS. And some of the remarks from StatHub or the accomplishments are they published recently the observations of Blue Walker 3 paper in Nature. You might have seen this. Very bright, very big satellite intended for communications directly to cell phones. They are right now on a few observation campaigns of the Starlink V2 Mini, Amazon Kuiper, and some other constellations. So anyone is interested in participating in this, either collecting data, processing data, you can contact the hub leads of SatHub and get involved. They are also planning infrared observations. First of all, on the ISS and Blue Walker 3, because they're very big. And then they want to move into smaller sizes of satellites, more satellites, but they want to understand how infrared emissions can affect telescopes. We are continue working on radio observations of UMR, unintended electromagnetic radiation, and also of satellite downlinks, right? Trying to better model satellite downlinks and the impact of satellite downlinks on radio astronomy. And the software development part of SatHub is also very much ongoing. We are working on 2 core packages at the moment. The idea of all of this is to produce free software for the community. So we are working on a satellite constellation observatory repository, which called SCORE. The idea there is that anyone will be able to submit their observations on satellites or observations polluted by satellites. So we create a big database that we can use for example, for machine learning or something like that. So that's the idea. And then the other thing we are working on is on a service which is called Sat Checker. And the idea there is that any observatory or observer can submit the details of their observation, and then they can get a detail on which satellites went through your field of view during their observation, which I think right now is the functionality it has because it's beta. But the idea is that in the future, it will have many more capabilities, like, for example, better planning of observations or post-processing, things like that. So again, if anyone is in the software development area and is interested in this, you can get involved in SatHub and collaborate with that. On Community Engagement Hub, we have a different flavor here of Hub, which is more like creating this bridge between the community of night sky users beyond professional astronomers, right? So we are trying there to reach not only the astronomy area, and not only the industry part, which is maybe the main ones we are discussing right now, but also opening up to any other interested groups that make use of the night sky. So for that, we are producing more or less, most of all, we are producing awareness. So we created this set of informative videos called SatCons 101 very simple, very short videos on different aspects, starting from what is a satellite constellation to what is optical and radio astronomy, how they can get in affected, and many other topics that relate to this. I think it's a set of 8 videos that each one lasts for about 6 minutes. So they're very useful tools. And we are also producing ready-to-use material for the astronomical community. So if anyone would like to make a presentation and needs like a slide that talks about this issue, you can go there and get some information. And we are basically trying to provide factual information to inform the public, right? And once we achieve that, then we will start collecting the reactions and what the feeling of the community is. I'll try to speed up a little bit more because I think I'm going too far. Just one remark is that the CPS itself does not advocate. So we rely on national societies and other groups that can advocate using our resources. So we produce resources so that other groups can advocate. And this is because the CPS was created like that, and we have very different stakeholders in the CPS. So we cannot really go and advocate. That's how we created the CPS. And again, the CPS has free and open membership. So if you are interested, please go into the website and apply for membership. And very quickly, I want to say a little bit on mitigations. Hopefully, this will bring someone to ask some questions. I said before, industry is working on reaching the 7 magnitude limit. They tried different things like painting the satellite black, putting visors, and now their latest thing is having reflector mirrors that diverts light away from satellites. They're working on modeling reflectivity of satellites. So it's software to model, depending on how the geometry and the materials are of the satellite, they can model how reflective it will be. They're making available the predictions of positions and velocity of satellites. This is very important so that we can use that for software. But right now, predictions are not as good as we might need them for astronomy. So that's something we are working on. There are some proposals also for mechanical shutters on optical telescopes, for example, that can work for some telescopes. Also some proposals of optical cameras alongside spectrometers, for example, to try to mitigate that or to know where the trails are and try to understand which fibers might be affected. On the radio side, we are discussing avoidance of radio telescopes from satellite constellations. For example, as you see there in this plot of the, sorry, there you see my mouse, of Starlink coverage service. You see these little spots are where the radio telescopes are, and they have a blank there, so they're not illuminating the sites. And there are some other discussions like avoiding beam-to-beam illumination, but that requires coordination with radio telescopes. So, but it's in discussion. And I think I'm done. Sorry, it went a little bit long. Thank you for your attention.
Thank you very much, Federico, for this very thorough discussion. We have 3 questions, but I think the 2 questions are better taken at the end, but there is a specific question that goes to your presentation from Genoveva Mishva. What information does SatChecker provide? If we want to know if a satellite passed through our field of view and hit fibers with a diameter of 1.5 arc seconds, is SatChecker information accurate and precise enough?
Yeah. Thanks, Genoveva, for the question. And at the moment, I would say no. It's not that accurate, and that's one of the challenges we need to address, right? That at the moment we are using normal TLEs or supplemental TLEs where they are, when we have them, and these are clearly not as accurate as we need them. So we need to work on that, and I would invite you to get involved in the discussion, especially maybe if you don't have the time to do the software development, that's okay. But on the discussion on the requirements, that will be very important for SatHub, so that we can push what we are doing right now and saying, okay, this is the accuracy we have, this is the one we need to get to. How do we do it?
Thank you, Federico. There is another question that I think is specifically related to this presentation. Where do you see the role of satellite laser ranging and space debris photometry here?
I would defer that one to the optical folks here, if you can help me. Yeah, I'm not a specialist on that part.
So honestly, me neither. But there are studies that show now, well, that discuss the fact that space debris is indeed going to become a real problem for instruments like Vera Rubin. So I do think there is a role about it, but I'm not a specialist specifically on that. I don't know if Robert knows more about this.
Not enough. I mean, oh, sorry, let me turn my video on. There we go. Not enough. I mean, look, I mean, I'm just thinking about the issue here, tracking all this stuff. I mean, it's an integral part of that, right? So it's adding to your data set more than anything. But then I'm just thinking about the SL. I know one or two people working in SLR here in the UK. I don't know whether they have a huge data set or whether they're, because you're talking about individual facilities, laser ranging. I don't know how many satellites they can track over the course for a night, for example. And when it gets up to the level of thousands, I'm not sure they've managed it. But it's an interesting question, and we should find out more.
It is, absolutely.
Yeah. So I can just
go ahead, Andy.
briefly comment on that, because I have had some interesting discussions with some companies recently that are actually developing technologies that they put an optical reflector on the satellite and then can use that to really get a high precision TLE, that's of the accuracy of meters. So once that system becomes ubiquitous, then that would really support us in terms of having much better TLEs. But I think part of the problem is that it's not seen as necessarily needed all over the industry, and there's a lot of technical and regulatory issues actually about increasing the number of lasers being beamed into space.
All right, thank you. There are more questions by Quentin, Paul, and Saskia that, however, we will take later, if you don't mind, after Andy's presentation. Andy is the External Relation Officer for ESO, and he's the co-chair of the IAU CPS Policy Hub. Andy, floor is yours.
Okay, thank you very much. It's great to be here. Do you see my screen there?
Yes, all good.
Yep, perfect. So yeah, I'm responsible for external relations at ESO, and one of the great pleasures of this role has been to represent the organization at the Committee on the Peaceful Uses of Outer Space, which is kind of how I ended up working on this topic of dark and quiet skies. So today I'm going to give you an update mainly about some of our policy work that we're doing, mainly as part of the IAU CPS Centre. But first, I just want to reflect on why this is important. So this is just one perspective. There are many views about why the night sky is important, but from the perspective of a major astronomical observatory, we need to consider and respect the public investments in science. So here you see the ELT. It's really happening. It's an amazing achievement of Europe, and this observatory will be present, hopefully, until the 2060s or the 2070s or even beyond. So that's a long time horizon, and this is much longer than the commercial time horizons that the space industry is operating. So we need to think long term. We need to take care of the night sky and think far into the future. And it's not just the ELT and ESO. Of course, there's many observatories that this is the case, substantial public investments. So we also need to take care of the radio sky. And I think in many ways, the problem is more challenging for the radio side long term. So yeah, I'm going to give you a quick update about the space policy context and talk about some of the work that we're doing at the IAU CPS. So as the other presenters have covered, there is a growing awareness of the the broader impacts of the commercialization of space and just the huge number of objects that's going up there, particularly into low Earth orbit. And now, beyond the issue of space debris, we see other concerns being raised, things like about the huge number of re-entries, the atmospheric effects, the potential to actually cause physical damage on the ground. I mean, if you do the math, we think about, okay, if there's going to be 100,000 satellites in low Earth orbit, I mean, this is a realistic number based on the projections. They tend to have a 5-year lifetime. So this means 20,000 satellites need to be added per year to keep the constellations the same, and 20,000 satellites deorbiting and re-entering each year. So that is a huge number. That's about 50 or 60 re-entries per day. So this is really raising concerns in the space community. And is it actually science fiction? I mean, is this number actually going to be achieved, this 100,000 number? And I think that it really is possible. So here is the SpaceX Starship. It took them 20 or so launches of the Falcon rocket to get it reusable. So it's not, it seemed likely that they could achieve the same with the Starship. And also reflecting on the fact that the Starship is, on the critical path of NASA's Artemis program. So they really need it to happen. And aside from the lunar exploration programs, the Starship will enable many hundreds of satellites to be put into low Earth orbit at once. So we need to pay attention. Now, we aren't the only ones that are paying attention. So the space industry over the past few decades, I would say, has really woken up to the fact that they need to think about sustainability because it's absolutely integral to their business model. So there's this, over the past few years, both on the political side, trying to raise awareness of the impacts of space activities on the space environment. There's numerous initiatives now, charters and declarations, and companies themselves trying to get ahead and thinking about sustainability. And it's not just sustainability. So there are other issues that are happening. The pace of technology is now allowing things like removal of debris, manufacturing in space, tourism, space-based solar power, and many other things. And then outside of low Earth orbit, the realistic possibility of mining from the moon or from asteroids. And what we're realizing now is that the regulatory frameworks for all these things is really not in place. It's very nascent. And coupled with the fact that there's now a very strong geopolitical driver behind this, particularly in the United States, and also very strong commercial pressures to clarify the regulatory landscape, we're actually in a new era of space policymaking, which for us is actually very good because it gives us a window of opportunity to act. So you can sketch the history of space governance or space policymaking like this. So we've gone through several distinct eras. So the first era was the creation of the UN treaties, the Outer Space Treaty, the Liability Treaty, the Registration Convention, and so on. And these are legally binding, high-level instruments that were created during the 1960s and 70s. And then at the height of the Cold War, treaty making became very difficult. So during the 1980s, we have this era of cooperation where more at the level of space agencies, there was initiatives that resulted in the International Space Station and many other things in terms of scientific cooperation. And challenges were being recognized, about the growth of the telecommunications industry, about new things like remote sensing and nuclear power sources in space. And somehow the UN committee was able to produce principles, statements that were not legally binding, but they are there. And then we're in this stage now, the era of guidelines, where the international community, for example, the long-term sustainability guidelines was finally created after almost 15 years in 2019. And this is not legally binding, but it's creating a kind of customary international law that there's a very strong compulsion for states to follow. But now, due to the things that I just mentioned, the really strong commercialization, states are really having to change the way that they're doing space policymaking. And so we're in now this new era of the creation of national space regulations, where many states all around the world are realizing that they have to have some systems in place to manage all these commercial activities. So this is a really good window of opportunity. And, we're in this window right now with a position to be able to influence, to some extent, states as they're developing new space policies. So as we mentioned, so one way that we're addressing this is acting at these international bodies, at COPUOS, at the ITU, and of course, the creation of the CPS. So I have the great pleasure at the moment to be the co-lead of what's called the Policy Hub. And here you see it's 5 core goals. So the most important one is raising awareness among space policymakers. A couple of years ago, no one was thinking about the impacts on astronomy, and now lots of people are. So this is a great success of our collective community. We need to be able to coordinate policy work of different national groups and facilitate interactions on proposals for new regulation, respond to public consultations in a coordinated way. And this is really important because we don't want one national society to be asking for one thing and then another to be asking for something completely different. It's really better if we're sort of generally heading in the same direction. The 4th goal there, traditionally, the world of spectrum management has kind of existed in its own bubble. And now we have this new situation where we're thinking about the effects on optical astronomy and the visual aspects of the night sky. And we need to make sure that these two systems are working together and coordinated. So I hope we're going to be standing up a new working group that will be taking care of that. And then the 5th one is we need to look at future threats, and we'll mention about that. And what we're trying to achieve overall is that, as I said, we're aligned in our messaging. We're consistently producing things that are influencing these space policymakers and, adding into the discussions that are ongoing and making both industry and both the government side aware of things. And of course, okay, there's an industry hub that the CPS has, which is great, but there's many people in industry that are paying very close attention to the development of space policy. So by virtue of our work, they will know about it. So one effort that we've done is to create a position paper. The sort of initial aim of this was to collect all the different recommendations that have been made in the SATCON conferences. So there was SATCON 1, SATCON 2 from the US. There was the Dark and Quiet Skies 1, the Dark and Quiet Skies 2, which were convened sort of under the framework of the UN. And many studies and recommendations, and we tried to put it all together in one place and define what the basic problem is, sketch out the overall strategy of what we're trying to work towards and give the recommendations and solutions. So it's in a beautiful, concise format. The work was led by Josh from MPFR as part of an EU-funded project, actually, the ORP Opticon RadioNet pilot project. So that was a really nice outcome. And I encourage you to please point your phone at that QR code and download it and share it as much as you can. So the next portion of work is, and this is the main point of my talk, is to give an update about our activities at the UN Committee on the Peaceful Uses of Outer Space. So this is a UN committee. There are 5 top UN committees, or maybe it's 6, that deal with various issues under the UN system. So we're under the 4th committee. And this is the only UN committee that is purely devoted to space topics. And it's actually now one of the largest, even maybe not the largest after the ITU, the largest committee in the UN system. So 102, probably more now, member states. So it's a very good awareness raising forum. And we now have 4 astronomy observers that are participating. So if you are an intergovernmental organization like ESO, like the Square Kilometre Array, or if you are an international non-profit organization like the IAU and the EAS, you have a right to be an observer, and you go through a process of application. So we can participate, but there's some things that we can't actually do. Like we can't comment on certain things in the same way that the member states can. But it's still fantastic to be there and in the room and to be able to have influence. So over the past couple of years, since the issue first emerged with the launch of Starlinks, we've really been working hard to try and get the topic of dark and quiet skies on the agenda. We've gone through organizing conferences, having many, many discussions with the member state delegations. And then finally, this February, it was achieved. So we got an agenda item on the committee. And overall, our long-term goal here is that we want some kind of UN-endorsed guidelines that are about the protection of dark and quiet skies. So we don't know yet exactly what form this will take. It's something that we need to figure out. I think we can safely say it's not going to be an international treaty because it's just the world situation won't allow that. But having some voluntary but customary international law type guidelines would be a great outcome. So yeah, we've got our 5-year agenda item: dark and quiet skies, astronomy and large constellations, addressing emerging issues and challenges. There's a long story behind that particular name, which I don't have time to explain, but it's very interesting. And because last year and the year before, it looked like the whole effort was going to crash down and we'd lose it, we formed this group called the Group of Friends, which was a group of states that were really interested in the subject and interested in seeing the issue being taken forward at the UN. So we formed this kind of informal group of friends. It's now led by Chile and Spain, and the IAU CPS is the secretariat. And the aim of this group was initially to try and see through some of the diplomatic challenges that we had last year and the year before. And now that we actually have an agenda item, the Group of Friends can take a more operational role and kind of coordinate our efforts as we move forward. So features about COPUOS, well, as other speakers have said, it's very slow. COPUOS works by consensus. So one single member state can object to something and derail everything. And this is what happened previously. So Russia, Iran, they objected to things. They have their own reasons for doing so, and it's likely nothing to do with astronomy. However, in the end, we broke through. But the positive things, COPUOS is giving us fantastic awareness. So 100+ member states. When an item is on the agenda, states have an opportunity to comment. But there's also this kind of normative pressure in a way to show progress. So essentially, states at the moment are in a way competing to show how well they are meeting these new long-term sustainability guidelines. So we'd hope to kind of generate the same dynamic with the dark and quiet skies. And another aspect, when states make an intervention, there's a kind of internal, I call it a bureaucratic cascade. So they've got to make a position, they've got to write a paper. There's some inter-agency, inter-ministerial coordination process. So, many different government groups get asked, okay, what's our position on this dark and quiet skies subject? What do you think? Have we done any studies? Have we asked our scientific community? So it creates this kind of growth of national activity, and this will then be replicated, hopefully, across multiple member states. So the next steps at COPUOS, then, we're going to we're starting to think about our overall strategy. How do we deal with this? How do we work with a group of friends? If you would like to get involved in this, you can seek out your national delegations because the interventions at COPUOS, it's quite tightly regulated and controlled. But I would encourage all the participants here to look into that. So I think I want to leave some time for the discussion. So I'm going to end on this last point that we did. So it was one of our first interventions at the legal subcommittee. So usually we've been operating in the science subcommittee. But as part of the CPS work, we convened a study that was asking a very simple question: are astronomical observations a form of exploration of outer space? And of course, the answer is patently obvious. Well, yes, they are. It's, you know, the original form of space exploration, but by linking it to the language and the interpretations in the Outer Space Treaty, this will have, I hope, an important effect. So the first thing is that states that are signatory to the Outer Space Treaty have obligations. They have to show due regard. They have to avoid potentially harmful interference. And if we're conducting space exploration via astronomy, then they have to show due regard to astronomy. And then the other aspect is that states conducting astronomical observations are engaging in the freedom of exploration, the freedom of scientific exploration in outer space. And those international facilities, we're encouraging international cooperation in this investigation. And this is language directly from the Outer Space Treaty. So this is now on record. It's in the legal subcommittee. Space lawyers in the future, will study this. And when countries are developing regulation, they will find this, and it will hopefully influence it in a kind of indirect way. So I was going to talk about the space policy consultations that we're doing. It's already been mentioned. We're also launching a future space technologies working group, looking at the impact on all these future activities that are coming beyond satellite constellations. It's very important. Space-based solar power is an interesting one. But let me just end on, okay, how can you help? Well, please consider joining the CPS. As Robert said, public awareness, pressure to governments is key. Find ways that you can get involved in national advisory committees. And then the last thing, astronomy resources. I mean, it takes a lot of effort to do all this work that we've just described. So, we observatories, future leaders in astronomy, you need to start thinking about the importance of really prioritizing spectrum management and devoting substantial resources to it. And then just generally policy work. So we need more effort on this. So that's all I have to say. So thank you.
Thank you very much, Andy, for this quick but very thorough summary of what's been going on this side. And thank you to all the speakers for their fantastic presentations. We have 5 questions already from the audience. Feel free to add more if you have anything you want to ask our speakers or you want to contribute to the discussion. The first question is from Quentin Parker, who asks, is this important topic part of the IAU discussion in South Africa? Federico.
Yeah, thanks. Briefly, yes, there are at least 2 parts or 3 parts in the IAU which are going to discuss this directly or indirectly. There is a 1-day CPS session on the 7th, if I remember correctly, but you can check on the program. There's a CPS session there. There is also a working group on dark and quiet skies at probably the 2nd week, which is also related to the topic, of course. And there's also a focus meeting, which is called Focus Meeting 5, which is discussing the future use of the radio spectrum for radio astronomy. So it's a little bit broader than this discussion, but it definitely includes discussions on satellite constellations on radio astronomy.
And Federico, maybe I can also just add to that there is a resolution, an IAU resolution that has been proposed, which is a high-level statement about the necessity and the importance of protecting dark and quiet skies. And again, this is one of these things where, if the IAU has a resolution, it becomes a form of potential customary law that states would have to absorb, given the status of the IAU, as a COPUOS observer and an international non-profit organization, having standing with the UN. So it's important to have these things on record.
Thank you, Andy. We have a question then from Paul Daniels, which I guess is for Robert. Robert Massey recently sent out a request for comments on the advent of LEO satellite advertising prompted by a Russian company proposal. Has he got a collated set of opinions on this yet?
Yeah, Paul's referring to something I did via the RAS actually, which is because John Barentine flagged it. It's a company, the Gagarin company, Advanced Space. Now, this is a Russian company this has happened a few times, but basically they've flagged the idea of space advertising again. They've done some launches. They want to do it with LED lasers and to create dot patterns that would create logos in the sky. They interestingly nodded to the idea that it wouldn't be visible over cities, over the rural areas, because they would switch it off. But actually, when you look at the practicalities of it, and Paul's actually done quite an extensive analysis of this, that turns out to be very unlikely. And if it goes ahead, it seems like it would be pretty detrimental. So I'm actually taking this to our governing council at the RAS on Friday. And it would be good. I can flag it with the EAS group as well. I think generally just opposing the principle of space advertising, actually, in the sense that you have something illuminated in the night sky as a way of displaying that. They're irrespective of the practicalities. I think it's important for us to oppose that. So, yeah, so in terms of a coherent set of views, well, Paul, most people just said, no, we don't want it, and raised in less detail than you have many of the things I've described, about the feasibility of this, but also that it would be very difficult to constrain it in the way they described. And even if it was only visible over cities, is that acceptable either, actually, was my other thought on it.
Thank you, Robert. We have a question from Saskia Hecker. There is no mention of NASA or ESA participating in any of these actions. Are they involved? So maybe Andy, want to take this?
Sure. So I know that in the American group, the American Astronomical Society, they have a working group, and they have the contacts with NASA. We do have some interactions with NASA via COPUOS, but that's in a kind of broader sense. However, the European Space Agency, so there's several things here. So they've just created what's called a Clean Space Program, which is a kind of internal effort to look at many aspects of space sustainability. And one of those efforts includes updating the ESA space debris mitigation standards, which every ESA mission must follow. And the latest version now includes something about dark and quiet skies. So that's, I think, an important outcome, because many European industry will then pay attention to what's in the ESA space debris standards. And then both ESO and the EAS are signatories to what's called the ESA Zero Debris Charter, which is one of these high-level political initiatives to get space actors and industry to commit to a zero debris world. It's very ambitious and challenging, but we managed to get a little bit of recognition in there on dark and quiet skies. And we're having a lot of internal discussions now with the kind of ESA system overall, and trying to find other potential hooks and ways that we can influence their internal programs to start thinking about this.
Thank you, Andy. And by the way, Andy has been instrumental in having dark and quiet sky mentioned in the Zero Debris Charter. Thank you for that, Andy, very much. Another question from Paul Daniels. Starlink satellites, and likely others, are moving towards use of lasers for inter-satellite communications. Has the impact of these lasers on orbiting observatories imaging been considered? Does anyone have an answer to this? I'm not aware of this being considered so far. No, okay. No.
So,
Andy, yep.
I mean, I can recall an initial study that was done by the ITU, essentially asking the question, do we need to start regulating this particular form of communications, extremely high bandwidth optical laser communications? And it was found that the interference potential is basically non-existent. So there's no particular need to try and regulate it. And I would, guess that probably roughly translates to the astronomy concern, and that there's no point having an optical communication system if there's going to be a lot of lost power due to scatter in the atmosphere and things, so that they're really trying to have very tight beams. However, I think that it's something that we should look at and pay attention to. So thank you for the question.
And the suggestion, indeed. Thank you, Andy, for the answer. Quentin Parker, HKU will host a Prim 2026 in Hong Kong in March. I am interested in making this topic a focus of the meeting. Please contact me if this is something that AES would support, and I imagine also the CBS board would be interested here. Thank you for this point, Quentin. We will get back to you. Joseph Trigo Rodriguez. Thank you so much for your useful presentation, and particularly leading a fiber network initiative in which we marginally detect wide field satellite transits. We have even recorded satellite reentries. Could you be interested in some of these video detections as examples of interference? I would say so, yeah. Federico, or I would imagine so, yes.
Yes, definitely. And sorry if I may, if it's for the purposes of raising awareness or campaigns like that, I'm sure that the community engagement group and our communications group in the CPS will be very interested on this. So I will type right now somewhere the email that you can use to contact them. Thanks. Thank you very much.
You can go to answer questions and add, if you want, add a written question there, which might be useful also to other attendees if they're interested in getting.
I think it would be useful for generally for raising awareness. Actually, putting just short clips and images and so on always help. So
I agree fully. It's always very useful to have that kind of image. Benjamin Winkle is making a comment and is actually, cheers to Andy for pointing out that the astro community needs to put more effort into spectrum management. At the moment, we put orders of magnitude more money to facilities and receivers and telescopes. Once the spectrum is gone, it's gone. Very good comment, Benjamin. Indeed, was a very good point that Andy made. Thank you for reminding us of that. Ronald Rimmer. Isn't ESA also promoting the idea of constructing a European mega constellation as well as a large solar arrays to transmit power to space? Andy, you want to take this?
Sure. So I'm not sure that promoting is the right word to use, but just in the general landscape of European space, ESA are fundamentally involved in the EU constellation in the same way that they were with Galileo and Copernicus and Sentinel and all the kind of European missions, so that they will play certainly an integral part of it. But that also gives us an opportunity to, another way to influence the space sustainability, dark and quiet skies requirements. And then the space-based solar power. So yeah, they are really studying this amongst many other countries, and it is a concern. And we've started dialogue with them actually about this particular concept. So there's space-based solar power from geostationary orbits, which capture the sunlight and then beam it back as microwave radiation. That's obviously a radio concern. And then there's another concept, which is having low Earth orbit reflectors, many thousands kilometer-sized mirrors, and that is pretty bad. So yeah, we are working with ESA on that to raise our concerns.
Thank you, Andy. Related to the European constellation, I would like to point out that it's not a mega constellation by any stretch of imagination. Of course, every constellation matters, and we want to make sure that even the small constellation take into account astronomy as one of the players of the astronomical community, as one of the players that might impact. But the European constellation R-squared is quite small by the numbers we've been talking about. That's quite small. We have another question, from Isabelle Grenier. What are the views of Asian and Indian space agencies and countries on sky pollution and debris growth? I'm not sure who wants to take this.
I can try.
Yep.
And then maybe Andy can chip in there. So we have not had so much inclusion of Asian and Indian colleagues in the CPS. Well, we do have astronomers, but we did have some interactions at COPUOS, and these delegations have been supportive of the protection of dark and quiet skies. So while the way they interact is very different from Western countries, right? So the way to reach government and getting support there is much more complicated. We've seen support for the protection of dark and quiet skies in COPWAS, which is very important, right? And in the last STSC in February, the Scientific and Technical Subcommittee, if I don't remember wrong, the statement by the Chinese delegation and by the Indian delegation did mention the protection of dark and quiet skies. So while I think they are not as vocal as some other countries, I think they are having an awareness raising of the situation, and they are also concerned.
Indeed. Thank you, Federico. I see no more questions. And in that case, I thank all the speakers for their wonderful presentations. Oh, not a question, sorry. Just one comment. I've recently seen news of MaxSpace developing large, inflatable, relatively inexpensive space structures up to 40 meters in diameter for habitation and research. These would be for use on the lunar surface and on lunar orbit, but could also be used in Earth orbit. Thank you for the comment, Paul. And we will close this now. Again, thank you to all the speakers and thank you to all the attendees. If you want to get in touch, both with the EAS or with any of the speakers, you can do so. You have Federico's email in the answers. You can contact through the EAS, who will be happy to provide direct emails to the speakers if you need them. I'm very happy of the turnout of the seminar, and this will be uploaded on the YouTube channel for the Society. And with this, I wish you a very good day. Bye-bye.
Thank you. Bye-bye.
Bye now.